Here is an explanation for the answer to final exam question number 41 in Alternative Energy Demystified 2nd edition. If you have the printed book, you'll find it on pages 318 and 319, split up between the pages. The question goes like this. The current that discharges in the atmospheric supercapacitor as averaged over time equals roughly what? Well, in order to answer that question, you will have had to pay close attention back in chapter 14 in the printed book. It is page 301 that'll tell you that the correct choice here is C, an average current of about 1,500 amperes. That may not sound like an awful lot. A good automotive battery has a cold cranking current of about 750 amperes. So that's about half of the average current that's discharging in the entire atmospheric supercapacitor. The secret to that, or the trick, is that this supercapacitor discharges in little bursts of amazingly intense current. Those little bursts are known as lightning strokes. And there's some very interesting phenomena that happen with lightning. They are not just confined, lightning strokes are not just confined to the clouds in the lower atmosphere. There's good evidence that those discharges extend well above those tops of those thunderclouds, and some people have actually observed them, calling them sprites and jets and other things. And a lot of that kind of experimentation, by the way, that kind of observation takes place pretty close to where I live here in the Black Hills of South Dakota. It takes place out in Wyoming, where they have an awful lot of thunderstorms in the summertime. We get a lot of them here in South Dakota in the summertime too. If you ever want to come out here in the summer, you better be ready for that. Hailstorms too. But anyway, this is a diagram. This is actually a little bit modified figure 14-6, showing the Earth, complete with latitude and longitude lines. There's our North Pole right there, or if you prefer, the South Pole. About 250,000 to 500,000 volts exists in this supercapacitor between the ionized layer, the ionosphere of the Earth, the lowest level of the ionosphere, called the D layer, and the Earth itself. The dielectric, or the insulator of this capacitor, is the atmosphere between the ionized layer and the Earth. This supercapacitor receives a constant supply of electrostatic charge courtesy of our great parent star, the Sun, and all of the particles that come from it, providing this voltage and this 1,500, roughly 1,500 amperes, 1,500. That is the average of these spikes of current which take place during thunderstorms and also to some extent in volcanoes and sandstorms on the Earth. Hurricanes, well, if you've ever been in a hurricane, that's a very interesting little scenario right there. I've been in some hurricanes that had practically no lightning in them at all. But you can hear those discharges on a good AM broadcast receiver, old-fashioned transistor radio. Remember those? You can hear them particularly at night, or if there are thunder showers in your vicinity. You will hear static crashes, also known as spherics, atmospheric noise on the radio. That is produced by those current discharges, spherics, electromagnetic pulses that are the result of these lightning discharges. But the average current, once again, the correct choice for this question is choice C, 1,500 amperes on the average are discharged in this capacitor.